All right, welcome everybody. Today we're going to go ahead and finish up section 7.3. We're going to take everything we did in the previous lesson, all of the factoring and all of the simplifying, and now we're going to extend it to multiplying and dividing rational expressions. So we're going to start with multiplying here on the front. Again, the key to success is still your ability to factor. So continue to practice, study, review that factoring table as needed. But here for multiplying rational expressions, you're going to factor as needed. Then you're going to cross cancel, not cross multiply, but cross cancel. That's what's going to allow you to reduce. You're going to want to make sure you simplify your final answer, and then you're going to want to state the domain restrictions, just like we were doing yesterday, meaning x cannot equal, y cannot equal, whatever the variables happen to be. Before we get into these harder versions, I just want to go back and review with you basic fraction multiplication reminders. Hopefully you remember back from your middle school days that when you multiply fractions, technically you're supposed to multiply the numerator times the numerator and the denominator times the denominator. By doing that, you're going to wind up with much larger numbers. So instead, you're going to try to cross cancel, again, not cross multiply, but cross cancel to go ahead and get smaller values. So 5 and 20, you notice that they have something in common, as do 6 and 2. So instead of multiplying those out to get larger numbers, you're going to cross cancel to make them smaller. So 5 divides into 5 once. 5 divides into 20 4 times. When it comes to the 2 and the 6, 2 divides into itself once. 2 divides into 6 3 times. Once you've gone ahead and do that, then you can go ahead and use those easy rules of multiplication, which says you're going to multiply the numerator times the numerator, which in this case would just be 1 times 1. You're then going to multiply the denominator times the denominator, which would be 3 times 4, and you're going to go ahead and wind up with a final answer of 1/12. Again, leave it as a fraction, no need to make it into a decimal. Notice again here, this is a basic problem, so there are no variables. So because there are no variables, we don't have to worry about any restrictions. We're going to go ahead and take that same idea and now extend it to harder examples. So take a look here at the next one. So again, you don't have to, but you might want to just remind yourself anytime you see a variable with no exponent, you of course want to remind yourself that it is technically a value of 1. So again, you're going to try to cross cancel anywhere that you can, and then in your final answer, multiply any remaining numerators and any remaining denominators. So if I take a look carefully at this 4, this 3, and this 12, hopefully you would agree that 4 times 3 is 12, so I can actually just cross out all of those values. Because there are no other constants, I know that I'm going to be left with a 5 in the in the denominator, so I'm going to go ahead and put that there. Then I'm going to go ahead and look for all the different A's. So notice there are 2 A's on top. And then all together, there are 5 A's on the bottom. So I'm going to try to cancel out as many as I can. So I can cancel this A entirely with one of these A's. And again, while we normally cross cancel, you can always reduce within a single fraction as well. So I'm going to reduce the A on top to just to the first. Then if I get rid of it all together, that's going to make this a to the third. And again, because there are no other A's, that's how I know that I'm left with 3 in the denominator. If I go ahead and look for all the B's, I see just 1 on top and I see 3 on the bottom. So if I try to reduce, I'm going to cancel all the B's on the top and then reduce the bottom to 2 of them. And then finally, I'm left with a C, and because there's only a C on top, there's nobody to reduce with, which means that's what I'm going to be left with here in my answer. So my final simplification is C over 5a to the third b squared. And then when it comes to my restrictions, you have to look at all of the denominators. Because there's an A and because there's a B, I have to say A cannot equal and I have to say B cannot equal. And the values that I have to choose are anything that would make the denominator 0. So because those A's and B's are singular with no additions or subtractions, I know that the restricted values are 0. So again, you have to make sure you have both here. You have to make sure you have 1, the simplification, and then 2, you have to make sure that you have the restrictions. So a few harder examples even still. Take a look here at number 3. Notice that instead of having just 2 fractions, you have 3 of them. The whole point here is to point out that you can cross cancel any top with any bottom, whether they're directly over each other or just any top with any bottom, just as long as you do them one quantity at a time. So again, in my final answer, I know I'm looking for a big old fraction. I want to just remind myself this is 5x to the first. So if I go ahead and start by looking at the constants, I'm going to cancel this 5 with this 5. Then I'm going to cancel this 6 with this 18, which is going to make a 3. Then I'm going to reduce this 3 with this 9, which leaves me with just a 3 up top. If I go ahead and look at the x's, there are 5 and 1 and then 7. So on the top, there are a total of 6 of them. On the bottom, there are a total of 7 of them, which means I can cancel 6 from the top. 7 minus 6 becomes x to the first, which means all I'm going to be left with for this big old multiplication is just a 3 over x. So again, that is my final answer. Then from here, I have to state my restrictions. The only variable in this case in the denominator is an x. So x cannot equal. Again, because the x has no addition or subtraction, the restriction is going to be that x does not equal 0. So the truth is, it doesn't really get all that much harder. As hard as it would get would be something here like number 4. Basically, in these problems, factoring is the key. I know in the last lesson, we kind of separated the factoring. Here, you just have to do it one step at a time. So I know that I'm going to have a fraction here, and I know that I'm going to have a fraction here. The first thing I notice is this x plus 4 obviously cannot be factored, so I'm going to go ahead and just move it down. I'm going to put a parentheses around it, though, just to make sure I know that that x and that 4 has to stay together. Then I'm going to go ahead and start by factoring the top left here. So because this is a trinomial, just with a coefficient of 1, I know that I'm just going to need x and x, and the truth is that's going to be the case for all of these. So here for the orange, factors of negative 12 that add up to be positive 4, that would have to be a 6 and a 2. And it would have to be a positive negative in order for that to work. Multiply to be negative 12, add up to be positive 4. Then if I take a look at the denominator, I'm looking for factors of positive 30 that add to be 11. So those would be positive 5 and positive 6. And just to reiterate, it doesn't matter the order that you put the factors in. If you put the x plus 6 first, that would be perfectly acceptable. Then take a look at x squared minus 2x minus 35. So factors of 35 that somehow make a 2. I believe I need a 7 and a 5. And it would have to be a negative and a positive. And now that everything is factored, I'm going to go ahead and try to reduce any top with any bottom, as long as I do them just one set at a time. So I spy an x plus 6 and an x plus 6. Again, it doesn't matter if they are in the same fraction or the opposite fractions. I am definitely allowed to cancel those. Similarly, with the x plus 5 and the x plus 5, those are exactly the same. So I'm going to go ahead and cancel those. There are no other common factors to the top and bottom. So in the final answer, I'm going to wind up with an x minus 2 times an x minus 7 up top over an x plus 4 down low. Couple things to point out here in the answer. You do not have to multiply out the top. In fact, it's recommended that you don't, because if you do, you could just lead to a mistake. The x plus 4 on the bottom, you don't have to put in parentheses, but again, it might be a good idea just for you to remember not to try to cancel any farther. And then finally, for your restrictions. In order to state your restrictions, you have to look at each value in the denominator, and any value that makes each parentheses a 0, you would have to eliminate. So if you look at the x plus 6, x cannot equal negative 6. If you look at the x plus 5, it can't equal negative 5. And if you look at the x plus 4, it can't equal negative 4. Typically, when you put restrictions, you list them in order from the smallest to the largest, although if you forget and just list them in any order, that would be fine as well. And then one more, hopefully should do it for you here. Again, trinomials with a coefficient of 1 are kind of the most popular factoring we're going to see, but please don't forget greatest common factor, sum and difference of cubes, difference of squares, all of that is available to you. So I'm going to start with the top left here. As I go ahead and start with the top left, notice here that, of course, it's only a binomial, so it does look a little bit different than the others. So here, I'm going to go ahead and start with just a greatest common factor. So the greatest common factor of x cubed plus 3x squared would obviously just be an x squared, and that would leave me with an x plus 3. If I look at the denominator, I again have a trinomial, And then because everything that's left is a trinomial, I'm going to go ahead and just do a bunch of parentheses. So here in the orange, factors of -6 that add up to be a +5. You always have to be careful when you see the 5 and 6 because your options are always 1 and 6 or 2 and 3. Because of the signs, it has to be 1 and 6, and then it has to be a negative positive. Again, if you're impressed by my factoring skills, obviously, you should be, but you can try to get better and better just by reviewing that factoring chart and again, pausing and trying it or doing the homework. Then up top, so here, we're going to be looking for factors of +9 that add up to be -10, and that looks like a 9 and a 1. And in order for that to work, I would need a double negative. And then finally, the bottom right here, so again, x and x, factors of 27 that make a 6 would have to be a 9 and a 3, and then it would have to be a negative and a positive. Here is probably my best tip for you as you go ahead and try these homework problems. The whole point of this section is that lots of things should cancel. So if you find yourself in a case where things are not canceling, that's kind of a clue to you that maybe you're not factoring correctly. So canceling is the most fun part. This x plus 3 with this x plus 3, this x minus 1 with this x minus 1, and this x minus 9 with this x minus 9, leaving you with just an x squared up top and an x plus 6 on the bottom. Again, feel free to put a parentheses around that denominator just to make it 100% clear that you cannot reduce any further. You cannot reduce those x's. The x belongs to the 6 and it has to stay there. For the last part of the puzzle here, state your restrictions. When you go to state your restrictions, again, you have to look at every denominator and you have to go ahead and tell me all the things that x cannot equal. So I'm going to go ahead and highlight each of these denominators. And again, any value of x that would make a 0, you have to go ahead and disregard. So x cannot equal -6 for the x plus 6, -3 for the x plus 3, 1 for the x minus 1, and 9 for the x minus 9. And again, we tend to list those in order from the smallest. Sorry, class notebook is doing that thing again. We tend to list them again from the smallest to the largest, but so long as you have them all in any order, that's really the most important part. Sorry, I should add my -6 there. All right, so now we're on to the back, and notice here on the back, we are going to be dividing rational expressions. If you take a look at the directions, notice that all the directions are exactly the same except for one part. In order to start the problem, you have to change the problem into multiplication by using the reciprocal. Then you're going to factor, cross cancel, reduce, simplify, and then again, state the domain. So again, let's start with a very basic fraction division back from your middle school days. Let's say you had 4/5 divided by 16/25. When you take division, whether it's a simple problem or a more complicated one, you want to do multiply by the reciprocal. Some of you might know it as keep, change, or keep, change, flip. But here's how it works for the easy versions. You're going to take the first value, which is 4/5, and you're going to leave it alone. That's where the keep comes from. Then the change, you're going to take this division and you are going to change it into a multiplication. Then you're going to take the second expression and you're going to either make it the reciprocal or you're going to change it or you're going to flip it, whatever of those words sounds familiar to you. So I'm going to change this into 25/16. So keep the first value, change the division to a multiplication, and then either flip, change, or do the reciprocal, whichever of those means more to you. And now the most important thing here, because you changed it into a multiplication, you're now going to go ahead and do it exactly the same way that we did the front side. So you're going to look at this 4, you're going to look at this 16, and you're going to say to yourself, okay, I can divide 4 by 4, I can divide 16 by 4, so I'm going to go ahead and reduce those. I'm going to look at the 5 and the 25. I'm going to divide 5 by itself. I'm going to divide 25 by 5. In my final answer, I know it's going to be a fraction. So top times top, which gives me 5. Bottom times bottom gives me 4. And again, leave it as a fraction. No need to turn it into a decimal. So I think it always helps to go back to an easy example before you try to do the harder ones. And again, because there are no variables, there are no restrictions. We're now going to apply that directly to this harder example here in number 7. Again, notice that it's a division. So from this point forward, anytime you see a division, you're going to start by leaving the first values exactly the same. So x plus 2, which again, I'm going to just put in a parenthesis so I remember they have to stick together. Then I'm going to change that division to a multiplication. That's kind of the most important step. Then I'm going to invert to create the reciprocal. So I'm going to move the denominator up to the top, and I'm going to move the numerator down to the bottom. And honestly, once you do that, now it's exactly the same as the previous page. So you're going to try to factor everything in sight. So starting with this first fraction here, and then again, multiplication, second fraction here, the x plus 2 looks to be good exactly as it is. Then if I look at the bottom left, factors of positive 24 that add up to be a 10. So that looks like 4 positive and 6 positive. Up top right here, I'm trying to find factors of negative 8 that add up to be positive 2. So it looks like I'm going to need a 4 and a 2. If you multiply those to get an 8, and then if you do plus minus, those will add up to be a 2. And then again, be careful. As much as we love factoring those trinomials, the bottom right is not a trinomial. All you're going to do here is factor out the greatest common factor, which is an x. Now that you've made it look exactly like the previous page, you're going to go ahead and try to cancel as many things as you can. Looks like the x plus 2s are going to be out. Looks like the x plus 4s are going to be out. And it looks like I'm going to be left with, get a little more room here. So up top, I'm going to be left with just an x minus 2, which again, I'm going to put in parentheses just to make clear. And then I'm left with an x plus 6 times an x. You do not have to multiply those together, but just so you know, it is considered better to put the x in the front. We tend to put the singles in front of the doubles. So here is my final answer. And again, that's it. You cannot cancel out any more x's. Anything you do at this point would be fake canceling. And then here is kind of the only other important difference between division and multiplication. When you are trying to find those domain restrictions, you have to check each denominator, including the original. Remember that when you did the flip, you took something that was originally in the denominator and you moved it to a numerator. But when you're doing the restrictions, you have to check every single step. So when I go to state the restrictions for this problem, if I'm saying x cannot equal, I'm going to kind of work backwards. So let me get my highlighting tool here. I'm going to go ahead and use an orange. Looking at my final answer here, looks like I cannot have 0 and I cannot have negative 6. Then if I go back one previous step and I look at all these denominators, you're going to go ahead and list any value that you haven't already listed. So you're going to have to go ahead and you're going to have to do a negative 2 for the canceled x plus 2. You're going to have to do a negative 4 for the canceled x plus 4. And then because of the fact that you have to check before you flipped it, you actually have to check this numerator as well. So the x plus 4 we already took care of. It's the x minus 2 that says I also cannot have a positive 2. So again, this is just one additional step that you have to do when it comes to division. You have to check every single denominator, including before you flipped it. And again, notice here I didn't list my restrictions in order, but again, it doesn't matter so long as you have them. So really just list them in whatever order is easiest. And that's it. So now just a couple more examples to make sure that we understand exactly what's what. So again, here in number 8, notice that you have that division. So the biggest, most important thing is to change that division into a multiplication. Unfortunately, if you don't do that, you're kind of dead in the water. And then the truth is, as you do more of these, you're going to maybe be getting better at better. So maybe you can flip and factor in the same step. So let's try it. So I'm going to go ahead and factor the original. So that's going to give me x plus 1 and 4. That's how I'm going to go ahead and be able to get that 5. Then I'm going to factor the denominator. So factors of 3 that add up to be 4 looks like 1 and 3. And then again, maybe you're able to factor and flip at the same time. So I'm going to factor x squared plus 3x. And remember, that's going to wind up in the numerator. So I'm going to factor out an x and then plus 3. That's a GCF. Then I'm going to take my x squared plus 3x minus 4. I'm going to factor it and flip it in the same step because I'm that good. Factors of -4 that make a 3 would be 4 and 1, and it would have to be a positive and a negative. Now's the fun part. Cancel everything in sight. So x plus 4s, x plus 1s, x plus 3s, and it looks like all I'm going to be left with in the top is an x, and all I'm going to be left with in the bottom is an x minus 1. And again, I like to put the x minus 1 in parentheses just as a reminder. Finally, I'm going to have to go ahead and I'm going to have to state my restrictions. And again, when you state your restrictions, you have to make sure that you check every single denominator, including before you flipped it. So here, I'm going to go ahead and use, let's see, what color did I use? Okay, back to orange. So looking at my final answer, that x minus 1, that's how I know that 1 is a restriction. Going back a previous step, I already took care of the 1. So now I need a -4 and a -1 and a -3. So -4, -1, -3. And then again, you have to check before you flipped it, which means you have to check this numerator as well. The -3 is already taken care of. So all I have to worry about is that lonely little x, which means I'm going to have to restrict 0 as well. Last but not least, take a look here at number 9. So here in number 9, this is a division problem, but notice it's just written in a slightly different format. Instead of having the division sign, it has this big division bar. When you see a problem in this format, this is called a complex fraction. There really isn't anything different about it other than the way that it looks. So I'm going to go ahead and start by, again, doing the keep, change, flip, or multiplying by the reciprocal. So in this case, I'm going to leave the numerator as x squared minus 2x minus 3 all over x squared minus 9. Then I'm going to change the big division bar into a multiplication, and I'm going to flip the bottom. And now all I have to do is factor and then reduce. So again, this multiplication is really the important part. So looks like top left, I'm going to need x minus 3 and x plus 1. Top right, x plus 3 and x minus 2. Bottom left, we haven't seen one of those today. So notice it's not a trinomial, but there also isn't a GCF. That is one of our other old friends, the difference of squares. We saw him last lesson. So the difference of squares, remember you have 2 parentheses, one positive, one negative. Square root of the front in the front, which is x, and square root of the back in the back, which is 3. And then bottom right, factors of 7 that make an 8. That's pretty simple, plus 1 and plus 7. Okay, and again, here's the good stuff. You're going to go ahead and try to cancel out as much as you can. So the x minus 3s, the x plus 3s, the x plus 1s. All you're going to be left with in your final answer is an x minus 2 over an x plus 7. And again, I like to put the parentheses to make sure you know that that's it, game over. You cannot reduce those x's. That is not allowed, not now, not ever. And then finally, go ahead and list all the restrictions. So again, you're going to be checking every denominator and then also the numerator of the flip. So this x plus 7, x plus 1, x plus 7 again. Remember, no need to do a repeat. So that gives me, I can't have a -7. I can't have a -1. I can't have a positive 3. I can't have a -3. And then again, if I check this denominator, so -3 I already have, positive 2 has to also be there. And then finally, that is everything that I'm going to need here for all my restrictions. So for these multiplications, and especially for the divisions, you wind up with a ton of restrictions, but usually you only have one variable. So at least that makes it a little bit simpler. So after today, you should be able to multiply and divide with ease. So thanks very much, guys, and we will catch you next time.